Hello students, you are welcome to Eko Learners Support for WAEC and NECO candidates. I'll be your teacher for this class, and in this class we'll be learning simultaneous equation. Yes, simultaneous equation. Sit back, let's enjoy learning together.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Simultaneous equation. So before now, as a mathematics student, we've learned several things about equation in mathematics. It's a mathematical statement that tells us that two algebraic expressions are equal. The basic part of it is the linear equation, which you have learned before now. So here we are looking at a more complex one, simultaneous equation. Our learning objectives. So by the end of the class, we will be able to, the students together should be able to identify simultaneous equations, solve any given simultaneous equation by substitution or elimination, and solve simultaneous equation involving fractions. So let's start. Simultaneous equation. Simultaneous equations are sets of linear equations that involves two or more common variables. Remember, in our linear equation, we've only learned that just one variable, and it's just one equation. Here in simultaneous equation, we always have two equations, or two or more as the case may be, but for this level, two equations with two variables that are common to the two equations. Example of this is where we have something like this, where this A and B, they are the coefficients of the variables x and y respectively, and C is a constant. So there are three methods of solving simultaneous equation. We have the substitution method, elimination method, and graphical method. But for the purpose of this class, we are going to be basing it on elimination and substitution method. Let's continue. Substitution method. When do we use it and what is it all about? This is better when coefficient of x or y is 1. So we use this method when the coefficient of x or y in any of the two equations is 1. Just as we experience in football game, when they say substitute, that means you take a player out of the pitch and bring a new player in. The same way here, simultaneous equation, we solve the two equations simultaneously. That's what makes it simultaneous equation. But we use substitution method when the coefficient of any of the variable is 1. It can be -1 or +1. Let's take, for example, here. We are to solve this simultaneously. Now, we have 2x plus y and 3x minus 2y equals 3. So interestingly, from the first equation, we have the variable y standing on its own. So to start with, we say from equation 1, let's make y the subject of the formula. Then that will become y equals 7. Remember, this is positive 2x. When you take it to the other side, it takes the sign of negative, minus 2x. So we keep this. We then move to equation 2. Equation 2, we substitute this y that we have made the subject of the formula. We then put it into equation 2, substituting y, that is 7 minus 2x, into that equation 2. It becomes 3x minus 2. Remember, we are bringing in something new. So which is our y, which is 7 minus 2x equals 3. This that we are bringing on board now. Then we know what to do. Open the bracket and solve for the value of x. which becomes 3x. Take negative 2 to multiply 7. Negative 14, that's minus 14. When negative multiplies negative, give us positive. That's plus 4x, then equals 3. Isn't that interesting? Now, we have 3x and we have 4x. So we can combine that to give us 7x minus 14 equals 3. Next thing for us here is to make x the subject. So in doing that, it becomes 7x equals 3. This is negative 14. You take it to the other side, becomes positive, plus 14. So we have 7x equals 17. Okay, 17. Then we divide through by that coefficient of x, which is 7. That will be x equals 17 divided by 7. So you know what that will give us. But try not to express this in decimal. Make it fraction. 7 goes here 2 times. What else do we have? We have 3. So 3 over 7. And that is the value for x that satisfies those two equations. We then go back. Now that we have the value of x, we then go back to our y to substitute the value of x into what it is here in our y. So we have it to become y is equals to 7 minus 2, open bracket, the value of our x earlier, which is 2 number, 3 over 7. Or better still, you still go on with the 17 over 7. They still mean the same. 17 divided by 7. So by the time you'll be done with this, you will have left we can bring this on board here to say we have y will be equals to 7 minus, you multiply this by 2, that gives us 4, 3 divided by 7. So very easy, you can find the value of y, where y will be equals to, wait, you probably want to find the LCM of this. Yes, it will work. However, you may as well think about it. Can 7 go here in 34? Yes. How many times? It will go 4 times. That will be 7 minus 4, whole number. So what do we have left? 6 over 7. Now, the first way as a WAEC student, when you take away 4 from 7, it has 3 left. That means we still have 3. This is 6 over 7. It's a fraction. For it to complete 1, it remains 1 over 7. So take that 1 over 7 from the 3 you are having left. We have y is equals to 2 whole number 1 over 7. And with that, we've been able to say, for this equation, our y is equals to 2 whole number 1 over 7, and our x is equals to 2 whole number 3 over 7. All right, now we move to elimination method. For elimination method, this is best when we have coefficients of x or y greater than 1 or greater than less than negative 1. Basically, when x and y in the two equations has a number before them, we consider elimination method. Just from the word eliminate, that means we have to eliminate one variable while we work on one. Then when we are done with that, we also eliminate that so that we can raise up the other one. And that is what we are going to be doing here. So to solve this, we have equation 1 and equation 2. Basically, let's just approach it in a simple way by saying 4x minus 3y equals 7. And equation 2 says 3x minus 2y equals 5. To make this simple, let's look for the coefficient of x that is at the front. Multiply each of these equations by the coefficient of the x. What am I saying? Look at this equation 1. Let's multiply it by the coefficient of x in equation 2. That is, we are multiplying through this 3. We are using 3 to multiply this. And we are going to be multiplying this with 4 so that we can have something new. If we multiply this, we are using this coefficient to multiply this. So 3 multiplied by 4, that gives us 12x minus, then 3 multiplied by 3y, that gives us 9y equals 3 multiplied by 7, that gives us 21. So we've gotten something new from what we are. Again, we then use the coefficient of x here in equation 1 to multiply the one of equation 2. So 4 multiplied by 3x, we have 12x minus 4 multiplied by 2y, we have 8y equals 4 multiplied by 5, we have 20. Now we've gotten something new. Interesting part of it is that you now see that the coefficient of x in the two new equations are the same, right? So at this point, the best way for us is to eliminate it. We can eliminate by saying subtract either of the equation from each other. If this is now equation star, I don't want us to have so many equations. If this one is equation star, star. So we can say subtract equation, which one would be easy for us? We can say subtract equation star from star, star. Let's not make mistake. That means this equation is what we are removing from this. So 12x minus 12x give us 0. So automatically x is eliminated. Now we have minus 9y is being taken away from minus 8y. Student makes mistake here. Let's try to do something here. This is minus 8y. That's the first thing. Minus, then minus 9y. So look at this. We are subtracting negative 9 from negative 8. So here, minus will multiply minus, it will become plus. So that means we have minus 8y plus 9y. That will give us just 1y. So that's what we now have. Y will be equals to, you remember that this one has become 0. It has been eliminated. Now we subtract 21 from 20. Don't forget, 20 comes first. 20 minus 21. Then that gives us what? Minus 1. So our y is negative 1. You see, elimination method. X has been eliminated, leaving us with y. Now that we know the value of y, can we then move on to substitute the value of y that we have already gotten into any of the two equations that we have earlier? I advise students, please, when you are substituting into the equation with smaller coefficient so that you can easily calculate it. So I can then say substitute minus 1 for y in equation 1. Or better still, 2. Just like I said, that we are using the one with the smaller coefficient. So this is equation 2. Put the value of y into that. It becomes 3x minus 2, open bracket. Remember, our y is minus 1, close bracket, equals 5. So we can then say this becomes 3x. Don't forget, negative multiplied by negative, that gives us positive. 2 multiplied by 1, that's 2. Then equals to 5. So I bet you can continue from this, where you say, subtract 2 from both sides. You have 3x equals 5 minus 2. Then you have 3x equals 3. So you divide both sides by the coefficient of x, which is 3. So 3 divided by 3 here, therefore x equals 1. Which means we've been able to solve for the problem that tells us that this equation, we have been able to determine the value of x and y that satisfy these two equations at the same time, simultaneously. That is why it is called simultaneous equation. Let's move on. This one is a simultaneous equation involving fractions. Simultaneous equation involving fraction. I want us to pay attention to this. Just similar to what we have been doing. But because it involves fraction, you need to be more technical in your approach. All right. Look at the first question where we have x over 2 plus 2y equals 3 and 3x over 2 minus 2y equals 1. To start with, let's rewrite this. X over 2 plus 2y equals 3, being our equation 1, and 3x over 2 minus 2y equals 1, being our equation 2. To minimize our time, look at equation number 1 and equation 2. The denominator here is 2. Here, the denominator is 1. Here, the denominator is 1. So when you find the LCM of 2 and 1, the LCM will still give you 2. Then, the simple approach, multiply equation 1 through by the LCM of all the denominators, which is 2. So when you multiply it by 2, each of the terms, 2 multiplied by x over 2, that will be 2 times x over 2. Remember, the 2 in the denominator, we cancel out the 2 you are using in multiplication. Then it gives birth to x. That's gone. You multiply this one by 2. Remember, 2y over 1 is the same thing as 2y. So you multiply it by 2. That gives you 4y equals, you also multiply this 3 by 2, making 6. That equation has been reproduced into something new, which we can say equation star. We do the same thing here. The LCM of all the denominators. Interestingly, this question, the denominator in the first term is 2, the second term 1, the third term 1. So the LCM of 2 and 1 is what we use. We use that to multiply through. So when I multiply this by 2, the 2 stays here. I use it to cancel out the 2 that is here. Why I'm doing this is I want you also to be part of this so that it doesn't be me alone writing everything. So you multiply this by 2, you have only 3x because the 2 you are using to multiply will have cancelled out the base. Minus, you multiply this by 2, it gives you 4y equals. So let's multiply this one by 2 again. It gives us 2. Now, the type of simultaneous equation that we are familiar with is now staring at us. Here, we start the journey. If you are to solve this type of simultaneous equation, then which method will you use and why? All right. You say substitution? Very good. Why? Because one of the variables is standing alone. So what we need to do now is make this variable the subject of the formula, substitute it into the second equation. So let's start from equation 1. So where the journey begins, from this equation 1, we have x equals 6 minus 4y. We already have value for x now. So we are now substituting this into equation 2 that we have here. We are substituting this into equation 2. So wherever we see x in this equation 2, 6 minus 4y, we take charge of it. Then it becomes 3x. This x minus 4y equals to, right? That's what we are doing. So this becomes 3, open bracket, 6 minus 4y minus 4y equals 2. If we do this, let's open the bracket. 18 minus 12y minus 4y equals 2. So it's easy for us from here to say 18, negative 12y and negative 4y gives us negative 16y equals 2. Here we then collect like terms. Collecting like terms means those terms that have the same variable, you pack them to one side of the equation. The other terms that share the same variable as well, in another manner, you pack them to the other side of the equation. So these whole numbers, I will let them come to the right side of the equation. It becomes minus 16y equals 2 minus 18. So we are left with minus 16y equals minus 16. Interesting. So you know what will happen? They have common thing here, minus 16. Divide both sides by the coefficient of y, which is minus 16. So y becomes minus 16 divided by minus 16, 1. Now we've gotten the value of y to be 1. We then need to move on to the value of x. We then go back into this that we have gotten earlier, substitute the value of y into this equation. So this becomes x equals 6 minus 4, open bracket, 1, close your bracket, x equals 6 minus 4, then x will be equals to 2. Hence, we've been able to determine the values of, the value of x and y that satisfy these two equations simultaneously. So for this equation now, x stands to be 2 and y stands to be 1. If you need to confirm it, put the value of x in this equation 1 and that of y in the equation 1. Let's see what it ends up to. 2 divided by 2, that's 1. 2 multiplied by 1, that's 2. 1 plus 2, 3. Fantastic. Let's try the same thing here. 3 multiplied by 2, that's 6. Divided by 2, we have 3. Minus 2 multiplied by 1, 2. So take 2 from 3, we have 1. If you really enjoy this, and I will leave you to try out this, but I won't leave you without giving you a clue. Look at this. 2, 3, 6. What will be the LCM? The LCM is 6. Multiply each of the terms by 6 to reduce it. Look at this. 2, 6, then 1. What will be the LCM? 6. Multiply each of the terms by 6 to reduce it to linear equation like this. If you All right, here we are going to be making provision to the solution for the practice question I gave you earlier. So let's look at this. I gave you a hint. To solve this, you look for the LCM of all the denominators here, which is 6. So you multiply each of the term by 6. Let's just say we are multiplying 6 by each of the term, which is all through y over 2 minus x over 3 equals 1 over 6. So multiplying 6 by we can say this will become 6y divided by 2. So when you divide it by 2, you have 3y minus, when you multiply 6 by x, that becomes 6x. Divided by 3 that we have here, you have 2x equals, this one will now be 6 divided by 6, giving you 1. So we've gotten new equation, we call it out equation 1. We do the same thing here. What is this? 2, 6, and 1. We multiply the whole of the terms by 6, which is the LCM of the denominators. So when you multiply by 6, you have 6x divided by 2. That will give you 3x minus 6y divided by 6, that will give you y, equals 6 multiplied by 5, that gives you 30. That's equation 2. Now we have simultaneous equation that we are familiar with. Here, you have another job to do, which is selecting the appropriate method. Remember, whenever any of the variable is standing alone, we use substitution. So it means from equation 2, from this equation 2, we then say, make y the subject of the formula, it becomes minus y equals 30 minus 3x. So to make it easy, you multiply through by negative 1. When you multiply minus y with minus 1, you get y equals, multiply negative 1 with 30, you get negative 30. Multiply negative 1 with negative 3x, you get plus 3x. Now that we've done this, we can then say, let's now substitute the value of y that we have gotten here into equation 1. Remember, we started from equation 2, so we are now taking this back into equation 1. So wherever we see y, we put in negative 30 plus 3x. So from that equation 1, it becomes 3 open bracket negative 30 plus 3x equals 1. So we open the bracket completely. That gives us negative 90 plus 9x equals 1. Collect like times, x equals 1. Whenever negative number moves from one side to the other, it takes to positive. So we have 7x equals 91 over 7. Then x will be equals to 91. Now that we have this, we divide both sides by the coefficient of x, which is 7. So if I divide this by 7, I will have x. Then I will divide this by 7, 91. That is 91 over 7. So if we now look at it, how many times can x go here? Or better still, if you do not find any reason to minimize it now, we can just substitute this value back into this place. But I don't know how that will be convenient for you as students. So we can say x equals 7 goes here. Let's look at it. 7 goes in 9. That's 1, remainder 2. 7 goes in 21. That's 3. So our x is 13 now. We are now bringing this value, this 13, into this y. Therefore, y will be equals to minus 30 plus 3 multiplied by 13. So your y becomes minus 30. When you multiply this, that's plus 39. So negative 30 plus 39, that gives us 9. Therefore, the values of x and y that satisfy this given simultaneous equation is that x equals 13, while y equals 9. I bet you find that interesting.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So, for questions and comments, contact us on our social media handle being displayed under your screen. Till we come your way next time, keep learning mathematics.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.